Hello, welcome to IBCC channel. In this video, we were talking about the BGP basic configuration. This basic configuration is based on the Cisco iOS. So here's configuration. The first thing is configure BGP neighbor. So this configuration is based on the Cisco iOS in the IPv4 address family. Since different iOS or different platform, they have a different command. So in the Cisco iOS routers, to configure the BGP neighbor, you do the conf t, then you type the router BGP, then follow the AS number. Under the router BGP content, you can configure the BGP router ID. So BGP router ID command here in the Cisco iOS is optional command. If you don't configure this command, the router will generate a BGP router ID automatically. However, this BGP router ID is really important the parts since BGP in the BGP open message, they always check the BGP router ID. So I suggest you put the BGP router ID configure here. Then next, you configure the neighbor, the command like this, the neighbor, then the neighbor's IP address, then another keyword, the remote AS, then you put the remote AS numbers here. So next command is optional command. So you can further specify what is the update source. So use this command neighbor IP address update source. So then put the source IP address. So take a look at this diagram. So we have AS100, AS200. So between the AS100 and AS200, we have a eBGP setup like this. So first, take a look at the eBGP setup. eBGP setup is on the R2 and R3. So on the R2 configurations, you go to the router BGP 100. We'll put the BGP router ID here. Put a router. Here, the router ID, we use a loopback IP address. So use a loopback IP address is, we can see that is the best practice. Although the BGP router IP can be only IP address, as long as it's unique. So here, the best practice is use loopback IP address. Then, if you want to build the eBGP with its neighbors, so you can see the neighbor, then you put the neighbor's IP address. For this case, the neighbor's IP address is 64.0.0.6 here, so that's the neighbor 64.0.0.6 here. Then remote AS. So from the R2's perspective, the remote AS is AS200, so put the AS200. That's it. For this side, R2 to build the eBGP to the R3 is just this command here. That should do the work. You go to the R3, you type the router BGP, his own AS number to 200 here. Then you can type the BGP router ID. Here I can use the 3333. So then you type the next is the router neighbor 64.0.0.5. That is a peer IP. So the .5 is here. So the remote AS, the remote AS from R3's perspective is AS100. So put the AS100. So as I do this R2 and R3 eBGP were built. Now we can take a look at the R1 and R2. R1 and R2 is inside the same AS, so we need this means we need to build the iBGP between the R1 and R2. In this config, we will build the iBGP over the loopback interface, right? So R1's loopback interface to R2's loopback interface, the BGP, so BGP source is 2. So here's configurations. So you can go to the R1 under the BGP configuration. You see the neighbor. So neighbor need to do the 10.255.0.2. This IP is R2's loopback IP address. Then the remote AS 100. So since it's the same AS, so you use the same AS here. The next command is important for this scenario. If you want to build the BGP on the loopback interface, right? So you have to use this command neighbor, then IP address, update the source with its own loopback. Otherwise, this connection, this BGP connection won't come up since it cannot, since it will, when BGP check, it must be check the peer's IP address, whether match its configuration or not. So you have to use this source, update the source. In the R2, you do the pretty much same concept. So under the router BGP 100, you do the neighbor IP address. Then this is the peer's IP address. Here it's R1's loopback IP address, 10.255.0.1. Then do the remote AS 100. So 100 is the same AS number, so we put the same AS number here. So next is an important one for this scenario. So you do the neighbor. So 10.255.0.1. The update source is 10.255.2.5.2. So that means if we R2 do that, so R2 send the open message to R1. R1 will check. So he check the R2's packet source address. Source address for R2 is 10.255.255.0.2. Whether this IP address is match his configuration or not. So in the R1's configuration, his neighbor is 10.255.0.2. So since it's matched, then they can establish the BGP sessions. So that is this is the command. That's what is the command do, right? So here I have mentioned, since you build the BGP over the loopback IP address, also BGP doesn't deal with internal connectivities. So BGP is based on BGP sessions is based on the TCP, right? So they request the IP connectivity between these two address, loopback 1 on the R1 and loopback 2 on the R2. So that means IP 10.255.0.1 can reach the IP address 10.255.0.2 by IGP. If these two loopback IP address cannot reach each other, then you cannot run BGP over that. So we can quick take a look at this concept in the lab. So here is the lab, right? So we can log into this routers and do the configuration. Take a look. So here, let's first build the eBGP first, right? So eBGP we need to build between the R2 and R3, right? Let's go to the R2. R2, scroll down to do like this, config BGP router BGP. So the AS number here is 100. Then you do the do the BGP router ID. That's is what I recommended you do this BGP router ID. It's 10.255.0.2, right? So then you do the neighbor. You can specify the neighbor. Neighbor is eBGP neighbor. That's just use a one hop with BGP. So that's 64.0.0. Other side is the 6, right? 6. So remote AS is 200. That's it. This side config is finished, right? So save it. Go to the R3. T router BGP, sorry, BGP 200, and here, since we use Cisco iOS, the BGP router ID command is optional. If I don't put this one, the router will generate this BGP router ID automatically. So let's don't put this one here. Then do the next command, do the neighbor, then do the 64.0.0.5 is here. It's a peer IP address of the R3, so 5. So remote as 100. What is a remote AS? Remote AS from R3's perspective is here. It's 100. So done. That's it. So that's enough. So let's see here. You can see the neighbor come up right away, right? So you can see show IP BGP summary. You can see it. Okay, you can see. Okay, this neighbors come up right away. If you want to see what is the router identifier, see here the router identifier. The router automatically put the router ID 64.0.0.6 as its router ID, since we didn't specify the router ID. BGP, take a look. See, we didn't put the router ID, right? Go to other side, take a look. Show IP BGP summary. So from here, you see the router identified. This is router ID. This is we specified like this, right? So if we specify router ID, the router will use that values. So the neighbors come up right away, right? You don't see only routes advertise each other. So we will talk about how to advertise routes in the next course. So okay, let's do the BGP, IBGP between the R1 and the R2 over their loopback IP address. Do this router BGP. Let's go to our BGP. In the R1, we go to the router BGP, right? So we do the neighbor. Then we do neighbor 10.255.0.2 and the remote. Since this is an IBGP, so it uses his own AS number here. So here, the important sense, if we want to do the IBGP over the loopback interface, we need this command, neighbor 10.255.0.2 and update source. Update source is on loopback 255.0.1. So update source, why is this update source? Oh, update source is just to do, okay, it's just this user interface name. Okay, interface name just look back 0 here. That's it. Okay, done. This side is done. In other side, let's do this. Show router BGP 100 neighbors. That's need to put the R1's loopback here. 0.1 remote as 100, run to the update source 10.255.0.1. Update source is 0. Oh, update source 1 don't have loop 0 command. We don't have loop 0, so I think it's 0. Okay, there's no loop back 0 here. Let's configure loop back 0. Sorry for that. T interface loop back 0. Loop 0 register address 10.255.0.2. 255.255.255 here. That's it. Let's go back to the BGP again. Neighbor 10.255.0.1 and update source loop back 0. Now let's take it. Okay, however, you don't see the IP address come up, show IP BGP summary. You don't see the next route come up, right? You see that it's never, here's up and down, should never, states show idle. So we explained the BGP neighbor state in the previous the videos. You can take a look. So here's why it did not come up, because when you pin this and the source with this loop back 0, you cannot pin because no routes, right? No routes between this 10.255.0.1 and 10.255.0.2. So we need to make this happen. So we need to create the routes, right? Create the IGP routes. So just use a simple ways. We create a static routes, IP routes. Pointing to the 10.255.0.1 host routes. 255.255.255.255. Next hop is 10.0.0.1. Okay. Do the other side. IP route 10.255.0.2 host routes. 55255. Next hop is here, right? From R1, this next hop is here. It's 10.0.0.2. Okay, let's pin. Save it. Go to the R2 and pin again. Now it's pinnable. So let's see if the BGP come up or not. BGP summary. Done. It's come up. Okay, here is we illustrate the basic BGP neighbor configuration. Okay, in the next video, we will talk about the BGP group the neighbors. Thank you for watching.